Hi, in this example we're going to be looking at another way of looking at using potential and kinetic energy. In this case is the Tower of Terror. So if you've been to the Gold Coast at Dreamworld, it's quite a good ride. What we're going to say here is at the bottom of the ride you're being accelerated to a speed of 200 kilometres per hour at the bottom. Alright, so what we want to know is how high do you need to make the tower in order to let the car go up. So what we're really going to be doing here is going to be working backwards. So we're going to be thinking at the bottom it's going to have kinetic energy, right? And then that's going to get converted at the top to potential energy. So we're going to be working backwards from the example I showed you before. Alright, so the first thing we need to do is we need to work out what 200 kilometers per hour works out to be. So if I divide that by 3.6, then that will tell me it's 55.56 meters per second. Right, so you need to make sure you're working in SI units. Beautiful. Now, obviously we can calculate the kinetic energy at the bottom by simply using that formula. So kinetic energy is equal to the half of the mass times by the velocity squared. Now let's say the cart weighs 500 kilos, or half a tonne, so then it's going to be half of 500 times 55.56 squared. So probably the easiest way to do this in your calculator is simply go squared, times that by 500, and then divide that by, or times by 0.5. So it's going to give me 771,605 joules. Alright, so that's what I need to write down. So 771,605 joules. Alright, so think about appropriate rounding off is pretty important with that. Now, another way of writing it more scientifically would be go 7.716 by 10 to the 245 joules. Okay, right in scientific notation. Now, the key thing here with this question is to say at the top, the kinetic energy is converted to potential energy. So at the top we know the potential energy is going to be equal to 7.716 by 10 to the 5 joules. Now if we think about what we know about potential energy is equal to M times G times H. Now, so if I'm going to do this one here, I know that 7.716 by 10 to the 5. We know the mass is going to be 500. We know gravity, well, we can either use 9.8 or 10, it doesn't really matter, and then the height. Okay, so you could have rearranged this equation also before then, and you could have said that H is equal to potential energy over mg. It's probably a better way of doing it because then you only have to write it once and you can actually go straight to the answer. So therefore H is equal to 7.716 by 10 to the 5 all over 500 times by 9.8. Right, so in your calculator, if you go back to it, see you've already got the answer in there from the previous bit. So really all I have to do is divide that by, now because you're dividing by two things you need to use a bracket in the bottom line. So it's going to be 500 times by 9.8. And then that will give you your speed. So that's, I mean not speed, but it will give you your height. It's 157.5 metres. So that means that the Tower of Terror will go 157.5 metres up the Tower of Terror. Now how high would you need to make that? Well, obviously you need to make the ride safe. So you might go, well, 10% margin of error or whatever that might be. So you might go, well, make it 170 metres or something like that. Alright, so you need to make sure you allow enough room for, let's say if the roller coaster or the coaster was going a little bit faster, that you're not going to actually hit it. Alright, so that's another example of using potential and kinetic energy. Now in Mythbusters there's a really classic episode where they use, it's called the elevator of death. And the myth goes something like, if you are falling in the elevator, if you jump at the bottom, you'll survive. Alright, so what we're going to do is we're going to look at the elevator. And so the elevator falls, and let's say the elevator falls 50 metres. Alright, so this elevator weighs a mass of, let's say, 400 kilograms. Alright, something like that. And if it's going to fall 50 metres, what we need to try and do is work out the velocity at the bottom. Now, from the previous video, we've got two ways of doing that. We can either work out the potential energy at the top and say that's equal to the kinetic energy. So we can say potential energy equals mgh. Alright, so and that would then be equal to the kinetic energy. Alright, so we could do that. So that would be simply 400. Gravity, we'll use 10 in this case, and 50. So that will allow me to say that's equal to 4,000 times 5. So that's equal to 20. 20 and one more 0. So it's going to be 200,000 joules. Alright, so that will be my potential energy. So therefore that's going to be my kinetic energy as well. So, and then what I can say is my kinetic energy is equal to a half mv squared. So therefore velocity is equal to, now the 2 goes at the bottom, up to the top, and the m goes down the bottom. And then we take the square root of all that. So it's 2 times kinetic energy over the mass. Right? So in this case that works out to be 2 lots of 200,000, or you could write that as 2 by 10 to the 5 joules. Scientific notation is probably a good way to do that. And then that's all over, what was the mass, 400. Okay, so, and then you can go to your calculator and you can work that out. Alright, so if we do the square root of 2 times by 2 to the power of 5, that's why it's quicker. My 2 didn't get in there. If I go insert and press 2, I'll just start again. Alright, so square root of, start again, the square root of 2 times by 2 to the power of 5, which is, that's a 200,000, and then I need to divide that by 400. And that gives me 31.62 metres per second. So if I then times that by 3.6, that's going to give me, 31.62 times by 3.6, that's going to give me 113.8 metres per second. Alright, so going back to here, so that's going to give me an answer of 113.86 metres per second. Now, obviously, when you start looking at the forces involved there, that's going to be quite an incredible force, and there's probably going to be no way you're going to be able to survive a crash like that. Now, remember, I had another way of doing this, so if I know the change in the potential energy, I could have also used this formula here. V is equal to the square root of 2gh, and that allows me just to go straight to the velocity. So gravity is, in this case we're using 10, and then the height difference is 50 metres. Alright, so then we go to our calculator. The square root of 2 times by 10 times by 50. Alright, and that gave us the same answer of 31.62. So when we times that by 3.6, we get the same answer. So you have a little shortcut there if you want to use it. Again, this particular case, what we're doing is we're using our potential energy being converted to kinetic energy. And we can do it the other way around as well. I could ask you how fast is this particular elevator being, how fast will it be going when it's only 20 metres off the ground? Okay, I could also ask you to work out its potential energy 20 metres off the ground and its kinetic energy 20 metres off the ground. Alright, so the other sort of things I can do, just a change in the height will allow me to work those things out. Anyway, I hope this helps. Make sure you catch up with me if you need some help.